Uh, hey guys, welcome to Talk with Nick again. And today we have Samuel, who have a background in cognitive science, psychology, neuroscience, and he's a master's student and have received a full Erasmus scholarship and have studied in different universities all across Europe, like VU Amsterdam. He have studied in Bordeaux University, and he have also got the fellowship or scholarship to study in Harvard University for 1 semester. So Samuel, thank you so much. I'm really excited to have you here because first of all, I have never interviewed anybody who has a Erasmus full scholarship, plus who is doing a hardcore neuroscience, including artificial intelligence and all these subjects. So it's really interesting to have you here.
Yeah, thank you, Nick, for having me here. It's a pleasure.
So Samuel, can you introduce yourself in brief?
Yeah, so briefly, I'm Italian. I'm 24 years old. I have a bachelor's in cognitive psychology, and then I did a master's in neuroscience with the Erasmus Mundus program. And right now I'm working on artificial intelligence. And so, yeah, my future, I see myself applying neuroscience concepts to artificial intelligence.
Well, that's great, and now I will start like you use different words like cognitive psychology, then you move to neuroscience, and then you move to artificial intelligence. So I believe there will be definitely a connections, and all the time you have learned some kind of skill sets and then you apply it into your other subjects. So what kind of subjects a student learn in cognitive psychology?
Yeah, so starting from my bachelor's, cognitive psychology, well, you study, so in my case, it was more focused on neuroscience. So I studied behavioral neuroscience, which is the neuroscientific study of the mind at the behavior level. So, for example, studying the behavior of mice in a cage. Then you have cellular neuroscience. So you use, for example, viruses and that kind of stuff to investigate what happens at the level of cells. I also did computational neuroscience. So you study basically mathematical models to investigate how the brain mechanisms support cognitive functions. And so, for example, that's what I did for my master's thesis as well. But then in cognitive psychology, you also study at the psychological level how, for example, different aspects of the human condition affect behavior. So, for example, we did a course on the psychology of personality, a course on the psychology of memory, and so on. So, of course, being a bachelor's is like, it's really broad at first, and then you can choose what to focus on later on.
So which subject picked up your interest, and how did you decide to go for your master's in neuroscience?
Yeah, so that's a good question. In my case, it was computational neuroscience, because I've always been really interested in mathematics, and also during my bachelor's, I started learning how to code, so that was pretty fun. And I don't know precisely the reason why I went into computational neuroscience specifically. I think it's because the idea of using, some specific skills that I had developed personally and apply those to what I was studying looked pretty fun and also challenging, because then during my master's, the first semester was pretty hard. Like, of course, switching from cognitive psychology to, in my case, it was kind of like cellular neuroscience. That was really hard. And, but at the same time, the fact that it was so challenging, kept my interest alive.
So what kind of subjects you were studying in your first semester? Like, what was the challenging part?
Well, the challenging part was the fact that most of my classmates had a background in those subjects already, while I didn't. The subjects were, for example, genetics, neuroscience, well then statistics. Luckily, I had a background in statistics already. But then, for example, neurogenomics, quite challenging. I didn't know anything about it before then. And also all sort of aspects related to cellular biology. That was really hard for me because, of course, cognitive psychology is here, cellular biology is here, like completely different things. But yeah, I think that the key for me was I was never interested in a specific problem. Like I was never interested in, let's say, learning, like becoming the greatest expert at a specific problem.
I understand.
I've always been interested in being able to look at the same problem from different perspectives, right? So once you understand what happens at the level of cognitive functions, but also at the level of brain areas and at the level of cells, and then you also switch to artificial intelligence, then I think it's interesting because you have these broad array of perspectives that you can use to look at the same problem in an interesting way and in a very original way. So yeah, that's what kept the interest alive for me.
That's really interesting, and I'm very happy to hear that because recently I have interviewed a lot of researchers and entrepreneurs, and they say the same thing, that they are studying a lot of different subjects. You don't have to study just one and become an expertise, but I believe that there is a more of a generalist approach rather than the specialist approach. Would you say that, like, in today's world we are going to a generalist approach? Because like the way I'm hearing you, you have studied cognitive psychology, there were so many subjects, then you studied neurogenomics, and then there is statistics, then there is genetics, and now you're using artificial intelligence. So it's really crazy how many subjects you have studied when you're trying to solve a particular problem. So would you say, like, in today's world we are going towards the generalist approach, and it would be much better if we are that way?
Yeah, I think that it's important to recognize that, for example, now, yes, I'm working on artificial intelligence, but a person who has done 5 years of computer science, of course, can code way better than me, has a way sharper computational thinking mindset. And so the fact that, someone decides to have these super broad and general background isn't necessarily a good thing per se, in the sense that, like, for example, if you give a computational problem again to someone who has a background in computer science, they can solve it way faster than me. The thing is, having these broad background can help, not much in terms of how fast you solve a problem, but on how originally you solve it. Because when you have these kind of broad background, then you can find links that that are not that intuitive to a person who is always focused on the same approach throughout their career. So I think that it's not necessarily better that we're going in this direction in terms of getting faster at solving problems, but it is better in terms of becoming more original at solving new challenges.
Definitely, very well said. I should not have used the word better. What I meant is that we need both journalist and a specialist and a collaborative approach to solve the problem. And like you mentioned, like that one who is a generalist will be able to solve a problem in more original way, and one who is a specialist will be able to solve a specific problem at a very fast speed. So
Yes.
very well said. Yeah, thank you. And after, when you were in your masters, you got an opportunity to study in Harvard for 1 semester. So you went there for some practical work or some coursework?
Yeah, so it was an internship. So basically, during my Erasmus Mundus masters, I did 4 semesters. The first was in Amsterdam, and I did coursework. So what I was saying before, genetics, statistics, neurogenomics, and so on. Then in the second semester, I went to Boston in Harvard to do an internship. And it was a computational neuroscience internship. So we focused on developing some software to improve fiber photometry, which is a technique that is used in behavioral neuroscience. And then, yeah, after that, I did a semester in Bordeaux. So again, courses. And then in the fourth one, I went back to Amsterdam to work on my thesis.
All right. So let's talk a little bit about your thesis. What is your thesis, and what are you finding in your thesis?
Yeah. So I believe that right now there are two really interesting areas in neuroscience. One of them is what I worked on during my thesis, and the other one is what I'm working on right now. So let me start with the thesis. So that's basically precision medicine. So precision medicine is an approach that tries to say, instead of focusing on what the best treatment for a patient is on average, so taking, let's say, 40 patients and finding out what the best treatment is on average, let's focus on understanding how the environmental and the genetic properties of that patient can help us develop a treatment that is tailored to that individual. So everything becomes much more personalized. And of course, the downside is that it's way more difficult to develop a treatment. But the upside is that once you manage to find a treatment that is personalized to that patient, it's of course more powerful. So the idea specifically in my internship was to so let me give a brief introduction on stem cells. So basically, with stem cells, let's say that you have a patient who has a rare disease. You can extract a skin sample and take those skin cells, reprogram them into brain cells, and now you have this network of neurons, right, with the same DNA as DNA of that patient. And you can basically work with a simplified model of that patient's neurons. And so in my case, the goal was to build a computational model that would basically look at the ratio between excitation and inhibition in those neurons. So every neuron has some excitatory properties in the sense that they make it more likely for the next neuron to fire and to send a signal. And some neurons have inhibitory properties, so they make it less likely for the next neuron to fire. And so an interesting measure in the brain is the EI ratio. So finding out the ratio between excitatory neurons and inhibitory neurons. And you find that when the EI ratio in a patient's brain is impaired, then a lot of cognitive functions start being really, really impaired. And so in my case, the idea was to develop a computational model that would measure the EI ratio of the patient's brain so that later on we could develop drugs that are tailored to that specific EI ratio. So that's the idea. Yeah, that's precision medicine.
That's really, really interesting. I didn't know that there are two sets of neurons that one can describe as the one that get excited and the one who gets inhibited. So we would not say that that the one who is getting inhibited a lot or the one who is getting excited a lot is a bad thing. Can you throw some light on a little bit fundamentals of the neurons that get excited, the neurons that get inhibited? So I would say that these neurons must be getting excited or inhibited by variety of functions. Like when you watch a sunlight, in a very simple language, when you watch a sunlight, there may be some neurons that get excited, and there may be some neurons that get inhibited, right?
Yeah.
And how would what you can describe, like one can understand himself in terms of that it's the neurons is getting excited or the neurons is getting inhibited? There is any relation, or like an individual or a layman could understand these things and implement in his daily life?
Yeah, well, if you're asking in terms of explaining a bit better what excitation and inhibition entail, the idea is when a certain neuron is excitatory, so every neuron sends an electrical signal or a chemical signal to other neurons, right? And so when a neuron is excitatory, it basically makes it more likely for the signal to get spread around. While when the neuron is inhibitory, it makes it less likely. And the fact that there's no intrinsic value in a neuron being excitatory or inhibitory, in the sense that what is really important, as I said before, is the ratio, right? So you want to have a network in which most neurons are excitatory and some neurons are inhibitory in order to preserve the balance in the network. But it's not like the fact that certain neurons get excited is not necessarily saying if all neurons become excitatory, my brain becomes more powerful. Like it's not at all like that. Like if all of your neurons become excitatory, you would die in like 2 seconds. That's not how it works. So inhibitory neurons are super important as well because they help preserve the balance of the network.
All right, that's great. Very well said. And now I can keep asking questions on this one, and the video will become very, very long. So I will just switch to the next part about artificial intelligence. Like your background was completely psychology and a little bit of biology. And how did you find it when you started learning and exploring artificial intelligence? And what kind of subjects or tools did you learn to make yourself stable in artificial intelligence?
Yeah, well, the idea is that for artificial intelligence, there are a lot of excellent online courses. So you can find on YouTube courses on machine learning and deep learning and reinforcement learning from world-class universities, and the quality is really high. So it was not difficult to keep up with how the field was evolving. In my case, I started 3-4 years ago, and it was more something like a side interest. It was not related specifically to my bachelor's or to my master's. It was something that I did during my free time, and I have to say that it's definitely challenging to learn the basic concepts, but once you learn really well the fundamentals, then it becomes really easier to delve into the field of AI. And so yeah, in my case, like that's what I was mentioning before. This is, in my opinion, the second more interesting direction for neuroscience. That is becoming a source of inspiration for artificial intelligence. So understanding the differences and the similarities between biological and artificial intelligence is something that can really help build machines that think in a sharper way and that are better at generalization.
That's really good. And would you say that all the biologists should learn a little bit of artificial intelligence, or should try to collaborate with one who knows artificial intelligence?
Well, I would say that, so before artificial intelligence, I would say it's important that all biologists learn how to code, because that's going to become necessary. Like right now, there are a lot of biologists who don't know how to code, but in like 20 years, that's going to be a problem. So yeah, my advice is learn how to code. For artificial intelligence, I would not say that it's necessary to necessarily apply artificial intelligence tools to biology. I would say that if you have a biology background and you want to, let's say, become a bit more original in your research, for sure collaborating with people who come from an artificial intelligence background can be of help. So yeah, like I think that artificial intelligence has a lot to give to the field of biology. And if you look at the recent breakthroughs, like I don't know, like protein folding and like other, like for example, other important companies in artificial intelligence collaborating with neurogenomics companies in order to deliver drugs that work better. I think that it is clear that artificial intelligence is becoming more and more important for the field of biology. So yeah, in short, my answer is not necessarily learn it, but collaborating with artificial intelligence researchers can be cool.
All right, that's great. Thank you so much, Samuel. I have learned a lot about many subjects today, and I hope this video brings value to a lot of young students, especially who are 18, 19, and trying to explore psychology, cognitive psychology, neuroscience, neurogenomics. So we have talked a lot about these things. We have talked specifics of the ideas. So, and thank you so much for your time. And I hope I will be posting this video as soon as possible and update you.
Yeah, that's cool. Thank you, Nick. Thank you for having me here. It was a pleasure.
It was nice.